All right, I'm going to go over some of these problems. As you can see, I usually copy and paste from an exam that doesn't have the answers on it. The only one that I could get today had answers already up there. So as you can see, the answer to number 21 is 2. However, I'm just going to go over how you go about getting that answer. So if I look and the question says, if the terminal side of angle theta passes through the point -3, -4, what is the value of secant theta? Well, I'm going to just draw. Remember, when you're dealing with angles on a coordinate grid, you really have two sides. You have one that is your initial side, and you have another that is your terminal side. They start off right on top of one another, and when you rotate one, so if I could rotate this red one off of, you create an angle. So this specific angle goes through the point -3, -4. Well, -3, -4 would be, about right here. You don't need to be exact for this exercise, but you can still draw your triangle. It's not a unit. It's not dealing with a unit circle, but you can still use the concept of right triangles. Now we know that this is -3 up here, and this is -4, which really indicates direction, not distance, because you can't have a negative length, but you can have a negative direction in terms of which way you're going. So I'm going to have -3 squared, put parentheses around that, plus -4 squared is equal to x squared. And I'm going to make this down here x, because I need to know this side. If they want to know secant, remember, secant is 1 over cosine of theta. So in order to know my cosine, I need to have the hypotenuse. Remember, cosine is adjacent over hypotenuse. Secant is the opposite, hypotenuse over adjacent. Not the opposite, but the reciprocal. So I need this other side. Well, if I go through and do all this, you get 9 plus 16 is equal to x squared. 25 is equal to x squared. And you get 5 is equal to x. All right, so we end up with 5 here. And that's my distance. So my adjacent, or this would be my angle theta. My cosine would be -3 over 5. So the cosine of theta is equal to -3 over 5. The secant is going to be the reciprocal, or 1 over cosine. So the secant of theta is equal to -5 over 3. All right, so that's why you get this answer. Okay, looking at number 22, it says when the inverse of tangent theta is sketched, its domain is what? So remember, when you're doing the inverse, it's tangent -1 of some ratio of sides is equal to theta. So basically, your domain is what you're plugging in. Remember, when you're dealing with trig functions, if you have a regular trig function, I'm going to go to the calculator here. If I have a regular trig function, I'm going to do tangent of an angle. So maybe tangent of 45. And what I'm going to get out, I'm going to get out a ratio of the opposite side to the adjacent side in a right triangle with an acute angle of 45. And let me see if I'm in degrees. I'm in radians, so actually, that really doesn't matter, but for this purpose, I'll just put it in degrees. And so I'll be tangent 45 again. So you're always either entering a radian measure or a degree measure in a regular with a regular trig function. If you want the inverse, you have to plug in the ratio of sides, or side measure, and let's just say it's 12 divided by over 5. And you get out an angle measure. So you get out an angle measure, you input a ratio of 2 sides. So We're going to go over this later in the year, pretty soon actually. But right now I'm just going to plug in tangent, the inverse tangent, into the calculator. So I'm going to have second tangent. I'm going to have x. I'm going to graph it. And I'm going to hit zoom 6 to take us back to the standard window. And I'm going to go back to radians now. Nothing for you guys really to write down on this one at this point, but I'm going to graph it. And remember, the only thing that's going to affect your domain is if there are values that are undefined, at which, if there are values of x that are undefined. So how can you tell that? Well, you can tell on the graph by if you see any gaps in the graph. You can also go to the table, and you can look down, and you can see, are there any? No, doesn't look that way. And again, I'm not going to go through this too much because we're going to be looking at this pretty soon, but the domain is all reals, and all reals would be indicated by negative infinity to infinity. All right, again, with number 23, you have the recursive sequence. So what's the third term? They give you the first term, and they give you a general idea, which is this one, in terms of just in general. So what you have to do in this situation is find the second term. So how am I going to find the second term? So a sub 2 is going to equal 1/2 a sub 2 minus 1. So if I'm looking for the second term, which I'm looking for the second term, you have to take 1/2 of a sub 2 minus 1, which is going back to the first term, because a sub 2 minus 1 is really a sub 1, which is -6. And then minus the term you're looking for here, which in this case we're looking for the second term, so this is going to be -2. And that's why the person who did this has this right here to find the second term right here. All right, and you have all right. People staring at me like I'm crazy because there's nobody in the room, just me. Anyway, so you have the second term, so that's going to give you, so a sub 2 is going to equal -3 minus 2, which is -5. So that means a sub 2 is equal to -5. Now to find a sub 3, you have to use the fact you know a sub 2 is -5. So if you look at what they did here, that's basically what they did. They plugged in -5. So a sub 3 is equal to 1/2 of a sub 3 minus 1, which is really going back to your a sub 2. So this is gonna plug in right here. So that's -5 minus 3, because you're looking for the third term. So that's why 3 goes over there. So a sub 3 is equal to 1/2 times -5 is -5 over 2 minus 3. -5 over 2 minus 3. Here's a little practice with fractions. It's going to be -5 over 2 minus 6 over 2, which equals -11 over 2. And that is the answer that they have. All right, looking at number 24, they give us some information here. And in the question it says, what is the equation of a circle with its center at 0, -2, and passing through the point 3, -5? You know, as I looked at this question, we want to know what the radius is. And I know you see the answer here and you see some work, but looking here, we basically have a circle. We know a couple of things. We know the center is here. We know it passes through this point. That's 5. All right, now, so that circle is basically going to be something like that. The problem is we need to know the radius. So in order to find the radius, you can use your concept of a squared plus b squared equals c squared, because this is going to be a right triangle. and the radius is going to be the hypotenuse of this right triangle. And this side over here, on the y-axis, well, you have to count 1, 2, 3. So it's going to be 3. It's really negative 3, but that negative is going to go away. I'll do the negative 3, but it's going to go away when we square. And then over how much? Well, that's 1, 2, 3. And we know that because if this is 0, negative 2, if this is 0, negative 2, and then we have this down here is going to be negative 5. We know that that's a difference of 3. All right, now over, we also know that's 3 because it went from, the x value went from 0 to 3. So the y value changed from negative 2 to 5, which is a change of 3. The x value changed from 0 to 3, which is also a change of 3. So we have negative 3 and 3. We want to find that. That's our radius. So we have negative 3 squared plus, that's wrong, negative 3 inside parentheses. So negative 3 squared plus 3 squared equals x squared. We end up with 18 is equal to x squared, and square root of 18 is equal to x. Anytime you have the equation of a circle, if we know that this is my radius, it's always the radius squared is going to be in there. So the radius squared means it's got to be one of these. All right? So hold on 1 second. Okay, now I can check my points. I'll check 3, negative 5. It's got to work in either one of these equations. So I'll check it in the one that doesn't appear to be the answer. And I'll try that. So it would be x, which is 3. So I'm plugging in my x and my y into this equation. So I'm going to have 3 plus 2, not 2, yes, 2. 3 plus 2 squared plus negative 5 squared is equal to 18. So I end up with 25 plus 25 is equal to 18. That obviously is not true. All right, now let's try the other equation. We're going to plug in 3 for x, so now I'm trying this one. So 3 squared plus negative 5 plus 2 squared is equal to 18. And that's going to be 9 plus negative 3 squared is equal to 18. And that gives me 9 plus 9 is equal to 18. And that is correct. Okay, looking at this last one. It says if angles A and B are complementary, then secant B equals. Well, in terms of sine and cosine, you have a relationship between them that sine of an angle is always going to be equal to cosine of 90 minus whatever the angle is here. So 90 minus 30. So sine of 30 is equal to cosine of 60. We can check that out. Let's go here. So sine of 30 and cosine. Let's go into degree mode. Enter. So sine of 30, let's do it again. Sine of 30 equals 0.5. Cosine of 60 equals 0.5. And you can kind of see that on the unit circle at the places where, you know, all the values match up. The only thing that happens between 30 and 60 is that the cosine and sine switch. So obviously at 60, the cosine is the same as the sine at 30 and vice versa. But it works for any angles. So if you have sine, let's just say 51. That's equal to the cosine of, well, what's 90 minus 51? I believe that's 39. Right? So they're equal. That's always the case. Well, it also is the case when you're dealing with the reciprocals, which are secant and cosecant. So secant of an angle of B is equal to the cosecant of 90 minus that angle, whatever it is. So if you had the secant of 25, that's equal to the cosecant of 65, and so on. So that's why you have that angle right, that answer right there, rather. All right, that's it. Hopefully I'll have up the next questions soon.